Hello everyone, I am Ajay. Welcome to online learning Mindtree training. Today we are going to solve previous year's Mindtree coding questions. Coming to our first problem, write a program to find the average of our first p multiples of an integer n. Okay, let's understand first what is multiples. Let's take example of 2. 2 into 1 is 2, into 2 is 4, into 3 is 6, and so on. So these are called the multiples of 2, and if you take the number 3, then it will be 3, 6, 9, 12, and so on. As per the question, we need to find the average of first p multiples of integer n. First multiple will be 2 here. First 2 multiples will be 2, 4. First 3 multiples will be 2, 4, 6. In this way, we need to find the first p multiples of an integer n, and after finding it, we need to sum it up and divide it with the total number, that is p, because as per we know the average definition, it is sum of all the data divided by the total data, that is sum of all the multiples divided by the total multiples that we are considering, that is the first p. That's why the denominator will be p. So this is how this is what we need to code it right now. And let's take the sample cases here. If we take the sample cases, this is the n, that is the integer, and this is the p. So we can see the average of given number for the first 5 multiples, that is the first 5 multiples of 6 will be 6, 12, 18, 25, 30. As per average definition, we need to first sum it up and divide by the total number, that is p. So after doing this, the output will be 18. So okay, there's a printing mistake here. Yeah, so now it will be 18. So this is how we need to code it. So basically, after hearing it, the basic approach everyone gets is to loop it out and sum it up and dividing it. We'll just do that approach, and we'll also follow another approach. First, let's discuss about the approach 1. I'm using the syntax of the Python to explain the approach here for now. As per the syntax, we'll first take the input of n, then p, none, then we need to find the average of it. So I'll just take a loop here. For I in range of, we know we want to start from, let's take the example of 6, then the first number will be definitely 6, so the number will be n itself, and till n into p plus 1, because we know that in the range function the n will not be considered, the n minus 1 will be considered in the iteration, so we will just increment it by 1, so that the n into p, that is the last value, should also be considered. And it's like the series like 6, 12, 18, and so on. So we can see that every time we want the series to be incremented by 6 itself, so that is by n itself. So we are just making the step counter as n here. We'll just loop it out and we'll just find the sum here, that is I, that is sum plus equal to I, and finally we'll just print sum divided by p. This is the basic approach everyone follows, and let's first code for this approach now. I'm creating a new file here. Okay, p multiples. So let's first take the input of n, then input of p, and as per our description, I'm using the for loop, starting number and the limit plus 1, so that the n will also be considered, and the step counter as n. and I'm declaring a variable sum at 0 initially, and I'm using sum equal to sum plus I, and at later I'm just dividing sum divided by p, because that is the average we want to find. Okay, let's run this. Okay, we'll use the same example, 6 and 5. Yeah, we got the correct output 18. We'll also see with the another input 3 comma 5, 3 5. Yeah, 9. It's correct. Then it's correct, but let's discuss one more approach here. This is the basic common approach when everyone gets while seeing the problem. If you see the series here, that is 6, 12, 18. I'll write it down here again. 6, 12, 18, 24, 30. This will be like first 5 multiples of number 6. This is the first sample case which we are considering. We studied in the 10th standard and even the +1, +2 standard that we can use arithmetic progression when there is a continuous increase with a common difference. So by taking that as a situation, we can just sum it up with the formula of the arithmetic progression. The formula for the arithmetic progression is basically like S of n, and this formula is used when we know the last term, that is n by 2 first plus last. This is the actual formula, and here the n is p here because that is the first p multiple, so we are considering here p. Then this is the basic formula for calculating sum, and for average, that is our final output, it will be sum divided by p, which is p divided by 2 into first plus last divided by p. P and p cancel, so the formula will be first plus last divided by 2, and the first we know that is 6, that is the n value here. Last will be definitely the last multiple of p, that is n into p, which is equal to 6 into 5, 30. So basically the formula is like n plus n into p divided by 2. Okay, first let's code this out. I'm just commenting all this. Okay, print n plus n into p divided by 2. 6, 5, 18. That's correct. And it's an example of what's the case, 3 and 5. Okay, 3, 5, 9.0. Yeah, it's absolutely correct. So our code is working fine now. Here we can understand that there is a lot of difference between the approach 1 and approach 2. If you see the approach 1, that is my commented approach. Here we are using the for loop and we are iterating it again and again. If we can see that it's basically like first p multiples, so the time complexity will be of this will be order of p. There's now how many number of multiples it wants, that will be its time complexity. But considering this, I'm just using a single formula, even if it has lakhs of data or the n value can be in a lakhs, in crores, or any kind of number. I'm just using this a single formula. So for this, the time complexity will be order of 1. So if you are looking for an optimistic solution for this problem, then this formula is the solution for this. Thank you.